Dear students, in the last session we discussed about PN junction diode of the module 1 semiconductor diodes and application. In this session we are going to discuss about rectification or the rectifier. Rectification is one of the important application of the diode. As you know, the diode is formed by combining the p-type semiconductor with the n-type semiconductor using the fabrication technique. So the phenomenon of converting the sinusoidal AC waveform into single polarity half cycle is called the rectification. The device or the circuit which performs this rectification is called the rectifier. Rectifier is a device or a circuit which converts AC voltage into pulsating DC voltage. Pulsating DC voltage means it is not the pure DC voltage, so which is the sum of the AC components and the DC components. The AC components are also called as ripples. Next we see the classification of the rectifier. Based on the number of diodes employed, based on the rectifier which conducts the voltage with respect to the half cycles, we classify the rectifiers into two types: half wave rectifier and full wave rectifier. In full wave rectifier, we will be studying center tapped full wave rectifier and bridge rectifier. Let us begin with the half wave rectifier. Half wave rectifier is the rectifier which conducts voltage or current only during the one half cycle of the input AC signal. In this circuit, input AC signal is applied to the diode through the transformer. During positive half cycle, the terminal A becomes positive and terminal B becomes negative, so that diode is forward biased. Since the diode is forward biased, it becomes short circuited and the current flowing to the load RL, and therefore output voltage exists across the load as shown in the figure. So in this waveform, it is observed that for the positive half cycle, the diode is on, and the negative half cycle, the diode is off, which means negative half cycle is suppressed. So the output current during the positive half cycle is obtained as I naught is equal to Im into sine omega t. Similarly, output voltage obtained during the positive half cycle V naught is equal to Vm into sine omega t, and it is half during the negative half cycle. There is no output voltage, there is no output current, which means I naught is equal to 0 and V naught is equal to 0 for the duration pi to 2 pi during the negative half cycle, and during positive half cycle the output voltage V naught is equal to Vm sin theta and I is equal to Im into sin theta for the duration 0 to pi. Advantages of the half wave rectifier. What are the disadvantages of the full half wave rectifier? Advantages and disadvantages of the half wave rectifier. First one is advantages of the half wave rectifier. So you observe the circuit of an half wave rectifier. It is very simple circuit. Only one diode is required. This is one of the advantage of the half wave rectifier. And there is no requirement of the center tap transformer for this half wave rectifier. That is also one of the advantage of half wave rectifier. Disadvantages of half wave rectifier. So ripple factor is too high. Gamma is equal to 1.21 and efficiency of rectification is low, which is only 40.6%. You will be observing or you will be watching this derivation of the ripple factor and efficiency of the rectification in the next session. And one more disadvantage of half wave rectifier is DC saturation of the transformer secondary winding takes place in the half wave rectifier, and transformer utilization factor of the half wave rectifier is low. To overcome these disadvantages, to improve the rectification efficiency, to reduce the ripple factor, so we go for the full wave rectifier where two diodes are employed. Full wave rectifier is the rectifier which conducts during both positive and the negative half cycles of the AC input. In a full wave rectifier, the current flows through the load for the entire cycle of the input from 0 to 2 pi. So full wave rectifiers are classified into two types. One is center tapped full wave rectifier and second one is bridge rectifier. Now we concentrate on the center tapped full wave rectifier. See, in the circuit, it is observed that two diodes are employed in this fully rectifier, and so this when you apply the input signal to the diodes through the transformer, so at the secondary windings of the transformer, you are observing that two off rectifier circuits. So one off rectifier circuit which conducts the voltage during one off cycle, and the another rectifier circuit which conducts voltage or the current during another off cycle, so that the rectifier conducts voltage or the current for the whole cycle of the AC input. See, in this diagram you are observing the waveforms during the positive half cycle. So during the positive half cycle, what happens? During the positive half cycle, terminal A is positive and terminal B is negative. Therefore, D1 is forward biased and D2 is reverse biased. Since the D1 is forward biased, it becomes short circuited and the current flowing through the load as shown in the figure. Similarly, during negative off cycle, terminal B becomes positive and terminal A becomes negative. Because of this, D2 is forward biased and D1 is reverse biased. Since the D2 is the forward biased, it becomes short circuited. Since the D1 is reverse biased, it becomes open circuited. Therefore, since D2 is forward biased, the current which flows through the load as shown in the figure. So in this waveform, you are observing that for both positive half cycle and negative half cycle, diodes are conducting. Diode D1 is conducting when during the positive half cycle. By the time the D2 is half, during negative half cycle, D1 is half and D2 is turned on. So for the entire cycle of the input voltage, the rectifier conducts the voltage or the current. Advantages and disadvantages of the full wave rectifier. So advantages of the full wave rectifier. Ripple factor is low. It is about 0.48. So in case of an off wave rectifier, ripple factor is high. It is 1.21, means 121%. And efficiency of rectification in the full wave rectifier is high. It is about 81.2%. You observe the efficiency of rectification in the half wave rectifier. It is 40.6%. It was low. Next advantage of the full wave rectifier is that no DC saturation of the transformer secondary winding takes place, and DC output voltage and load current are twice compared to the half wave rectifier. Disadvantages of the full wave rectifier. Center tapped full wave rectifier. It is expensive to manufacture a center tapped transformer which produces equal voltages on each half of the secondary windings. It is difficult to locate the center tap of the secondary windings. The output voltage is half of the secondary voltage. Diodes have high peak inverse voltage, larger in size and costlier since it consisting of center tapped. So the cost of the circuit is more. Peak inverse voltage of a diode is twice that of used in the half wave rectifier. Next is a bridge rectifier. To overcome the disadvantages of the center tapped, the full rectifier, where the center tapped rectifier circuit is complex and very difficult to manufacture, irrespective of more diodes used in the bridge rectifier. So in the bridge rectifier, 4 diodes are used to form the bridge network or the bridge circuit. See, in this rectifier circuit, so input AC signal is applied to the terminal A and terminal C, terminal A and terminal C through the transformer. Outputs are the B. Outputs is obtained at the terminal B and the D. During positive half cycle of the AC input signal, diodes D1 and D2 are forward biased. Since D1 and D2 are forward biased, these become short circuited, and diode D3 and D4 are reverse biased. It becomes open circuited. The path of the current is shown in the figure. See, during the positive half cycle, I will tell you once again, during positive half cycle, terminal K is positive and terminal L is negative. So, you know the direction of the conventional current. It flows from positive to negative. So when the terminal K is positive and L is negative, diode D1 is forward biased and D2 is forward biased, but the diode D3 and D4 are reverse biased, then the current flowing through the load as shown in the figure. Because of this current flow, the voltage developed across the load as shown in the figure. Output is obtained across the load for the positive half cycle. Similarly, during the negative half cycle, you are observing that K becomes negative and L becomes positive. Since K is negative and L is positive, diode D4 and D3 are forward biased and diode D1 and D2 are reverse biased. Since D4 and D3 are forward biased, it becomes short circuited and the flow of current is shown in the figure. Because of the current flowing through the load, the output voltage develops across the load. So from this, it is clear that during the positive half cycle, two diodes are forward biased and two diodes are reverse biased. And during the negative half cycle, the two diodes are forward biased and another two diodes are reverse biased. That shows that for the rectifier conducts the voltage or current for the entire full cycle of the input AC. What are the advantages and disadvantages of this bridge rectifier? Advantages: transformer cost is less. Center tap transformer is not required in the bridge rectifier. Peak inverse voltage of the diode is one of the diode used as a center tap rectifier, and it is the most important circuit used in the power supplies. Disadvantages of the bridge rectifier: it requires 4 diodes during each off cycle of the AC input. 2 diodes that conducts are in series, and therefore voltage drop in the internal resistance of rectifying unit will be twice as compared to center tapped circuits. So thank you for watching this video. So next we will see the what expressions of the DC current, then RMS value of the current, next RMS value of the voltage and the DC voltage, ripple factor and efficiency of rectification, and voltage regulation for both half wave and the full rectifier. Thank you.